Hello everyone. Harshit from lovely Professional University Phagwara, and today we will be learning about the topic of modules, and after that we will be doing some practice questions. So stay connected in this video. This video will actually get you guys through a lot of more concepts. Okay, I have got some questions out there, so we will be solving those questions. But before that, let's just understand the concept of modules. That what are modules actually? Okay, so let me just start, guys. Okay, so see, what's a module? Module is actually a library or code. Okay, module is actually a .py file, as we have learned in the previous lecture. .txt files are some files which are written in text. So a module is just a .py file. Okay, that's it. Okay, so the moment we save the code in a py file, we have created the module. Every code which we are saving, that's a module, guys. So that's what module actually is. Okay, so Python actually doesn't need any special declaration. The file name is the module name. Okay, if I have written a module name list.py, so that's my file name and that's also my module name. You see, are exist to solve one problem. As programs grow, we can't keep everything in one file. So modules let us split the code into logical reusable places. Okay, logical reusable places. What do I mean by that? There are some modules. Okay, for most well-known module is the math module. Okay, so that math module actually covers a large area of our math library. Okay, of that math library, it covers square roots, squares, multiplication, addition, everything the math module actually covers. Okay, so it's actually splitting the code into some logical reusable places. Okay, now another thing, it actually avoids modules, let us avoid naming collections. Okay, that means two files each can have a function called run without a conflict. Okay, so third point is we can reuse the codes across a project without copy pasting. Okay, so we can just import a module and we can just copy paste anything. So let's just move towards my first module. So what can be my first module? Let's just create a module in which we are printing hello. Okay, in which we are printing hello. So wait, let me just start with my module part. Okay, so yeah, as soon as I'm writing my function def greeting. Okay, and inside it I'm writing a parameter, and after this I'll write print in, then comma, the name. This is my function. Okay, so after this I'll just do nothing. I'll just get exit from my function, and now so sorry. So now what's happening here is what actually I can do is I can save this module. Okay, and after I can save this module, I can just write I can then after it I can actually import this. So what's the solution for this? Is import greeting. Okay. So after this import greeting, I can actually work inside it, and I can just write print. Module name greeting. Okay. So why this I have actually raised that because I'm on an online compiler. Okay. I'm on an online interpreter. So this module is actually not getting saved. Okay, this function is not getting saved. That's why this import greeting is not working. But if you guys are doing it on VS Code, you guys can actually save that Python file and you guys can always call that code. Okay, so let's just move towards our next part. How can we actually import a module if we want it? Okay, how can I actually import any module? So let's just take an example of our math module. So for importing a module, I'll just write the import keyword, then I'll just write math, okay, and then after that import math, I can actually use it. So what's happening actually is that what's happening right here is that there's the whole idea of import and that module name. It actually runs the file in the background, okay, top to bottom runs and gives us a output, is irrespective respective to our inputs, okay, and whose attributes are everything defined in that file, okay, functions, classes, variables, everything. Okay. Now there are many ways to actually import a module. I can just paste them right now. There are many ways to import a module, and these are some ways to import that particular module. So first one is import the module name. Then there is import module name as the, so that I don't have to ram the whole word again and again. I don't have to ram the whole word again and again. Then from greeting import hello as hi. We can actually rename it, okay, or we can actually bring hello directly into our next namespace, okay. Then from greetings import hello and goodbye. So we are actually doing the multiple names. You are actually getting the multiple names. And then from module name import star. That means everything we can actually see. Okay, so that's how we can actually import from multiple views. Now, the most common math library. Okay, but before that, we want to talk about the rule of thumb. Okay, so the rule of thumb actually says that import module is safest, no namespace pollution, all, and it's always clear where something came from. Okay, from module import name is a fine for couple of well-known names, but you know, from module import aspect is almost always a bad idea in production code because it make it unclear where a name came from and can silently overwrite on our own video. Okay, so now let's just understand what's happening when when we are writing import. So this is the part that actually makes everything else click. Okay, when Python hits import and then module name, it actually checks the sys.modules. Okay, it's a cache cache dictionary of every module already imported in this run. Okay, so if it's there, Python just hands us the cached object, and this is why a module top level code only runs once, no matter how many times you import it from different files. Okay, if not cached, you will be thinking that what if it's not cached? So if not cached, it searches the sys path. So it sees below it. Okay. So for greeting.py or for any module.py, it searches paths. Then after that, it actually compiles it to bytecode. Okay. Bytecode is actually cached in a it's actually cached in a path. That path is most likely is underscore py cache underscore backslash greet module name dot c python and then its extension. Okay, so it's that file, so it doesn't need recompiling next time as long as the source isn't changed. Okay, now the fourth thing which is happening there is that it executes the file from top to bottom. Okay, so that it's building a module object of out of everything defined, guys. So now after this, what's happening is this: it stores the module in sys.modules and blinds the name of our module in our current namespace. Okay, so that's how we can actually see. Now, let's now there is every module has its own metadata. So that metadata of that module is what we can actually search. Okay, on from which we can actually search it. Now, after that, let's just understand that how we are actually using the modules and all. So, if I'm writing, if I'm writing any module, I guess I'll say import math. Okay, so I'll just write import math. Okay, then I'll just write a is equals to sqrt. Okay, It's not gonna work right here, but let me just open my Visual Studio so that it will work right there. So wait, let me just open my Visual Studio really quick. Now, as you guys can see, I have opened my Visual Studio code also. So, so now what's happening here is that now it's not Visual Studio code. Let me just move my camera a bit, okay, so that you guys can actually see the whole. Okay. So I have opened my Visual Studio right here. Okay. Now, when I'm working with it, I can just write import, and then there is libraries, import math. So this math is actually a library. Now, as soon as I just write a is equals to int, then this input, and then there is another enter on them. Okay. Now, as soon as I write b is equals to sqrt, okay, then we, oh, wait, then we can actually import into our math library. Okay. So there must be something. Okay. So now, as soon as I just leave, I, I will just now print my whole code, print b, okay. Now, as I just move towards my things, okay, now I just run this file in the terminal. It will first ask me to enter a number. Okay. Enter a number. Okay. Now I'll enter a series of numbers. Now, okay, wait, let me just check it really quick, okay, so that I can actually check something. Okay. So error right here. Okay. So during that, I'll also have to write the module name also. So as soon as I enter it, is supposed to, let me just put random numbers. Okay. So well, let me just put a number on each square root and 100. Okay. So now b is equals to, now b is equals to, wait, b is equals to math dot srd. And then I just put a here. Now, as soon as I write the print these statements, I'll get my code. Let's see, I've got my output as string. So, for using any function from a module, we can we actually have to write the module name dot and whatever function it's carrying. If I just try, so if I want to calculate the value of sine 45, so I can write math instead of SQRT, I can write sine. Okay, and now as soon as I just run this, I'll get my value of sine 45, which is 0.85. Okay, so that's how we can actually run the modules and we can actually work with them. So we will be working with the math module. Okay, so what's happening here is inside this math module, it's very useful for us. So I'm going to create a function which calculates the area. So for the area, we need to square a number. Okay, so for the squaring a number, let me just create that function right now really quick. So I'll just write def. Okay, so def area. Then we'll get an input as A. Okay, now after this input A, I can actually write. I can actually write that right here is that B is equal to math dot sq. Okay, I can square root it, but I can't use it. I can square it. Okay. So let's just create a function actually finds the that actually finds the side of a area of a triangle. Okay, so the area of a triangle is half into base into. No, instead of that, we can actually use that with the help of okay, something by which we can use the square root function. Okay, square root from the math module. So what we can actually do right here is I can actually write one thing. I can actually write one thing really quick. Like, yeah, I can actually write one thing really quick, which is getting the Pythagoras theorem. Okay, so for that Pythagoras theorem, what's the Pythagoras theorem says that hypotenuse is equals to under root of a square plus b square. Okay, so I can just write here a comma b will be two different things. So now I'll just write a asterisk equals to a. Okay, after this I'll write b asterisk equals to b. Now after all this, I'll just write c is equals to math dot sqrt in bracket then a plus b. Okay, and then I'll just do one thing. I'll just do the return c. And now when I'm printing my code, I can just write print area. Okay, then I have to remove this from here. Print area bracket. Let me just take two different ones, 12 and 13. Now as I just run my code out here, I have 17.69. Okay. So let me just calculate that if it's true or not. So the square of 12 is 144. Okay. So the square of 12 is 144. Okay. Then the square of 13 is 169. Okay. I know that, but I'm just taking around. Okay. 169. Okay. So now 144 plus 169. Okay. So it's 313. Okay. Now as soon as I do the square root of 313, I have my number as 17.69. See, that's my number 17.69. Now this one is for the finding of square roots when we know the base and the height. But what if we knew the hypotenuse? Then we just put when we are using the hyperlinks, we'll just put a negative sign and I'll just run this through. Okay, what's happening here? Right now, I'm able to put in the code perfectly. If I write that code perfectly, it will be more like it will be containing an if-else statement that if a, a is greater than b, then proceed towards this c. Then after that also, that's how we are actually writing that particular code. Okay. So, but now, right now, it has given me another output. So that's how we can actually use the import import modules. Okay, it's very useful for us right now nowadays, so that we can actually do the small things. Okay, now let's just create a function using the math module also, which says depth area. Okay, and I'll get a aim. Okay, now after this a, I'll just put c equals to math dot. What's the area of a circle? The area of a circle is pi into. So I'll just write pi. Okay, is equals to math.py. Okay, now for the area, I'll create another variable d is equals to c asterisk a asterisk a. Okay, and then I'll just write return d. No, I'm right. I'm creating another variable right now, right here. But you guys can actually return the statement at once. Okay, you guys can actually write return instead of this d, so that it's up to you guys. Okay. Now, as soon as I just now I'll print my code. Okay, print. What number can I print? Print 2. Okay. And now if I just enter it, oh, not print 2, print area into 2. Okay. Print area bracket 2. Okay. So now I'll just do this and I'll get my output is 12.56. So let me just check really quick on my calculator that if it's actually correct or not. So what I'm doing is I'm just multiplying the pi multiplied by 2 multiplied by 2. So yeah, it's really 12.56. Okay, you guys can actually see it right here. So it's correct. So we have actually created a function that actually calculates the area. So if someone doesn't know the value of pi, they can actually get it with the help of import math. Okay, so that's how these modules are actually helping us. These are very helpful to us. Okay, now I can actually show you the reading part also. If I just want. Okay, so let me just try. Let me do one thing. Just remove this and just come down to this one. Let me just remove this print also. Okay, now it's my one function. Now, if I just go to a new text file, okay, new text file I'm going to create, and for this file, wait, let me just do I just create new file. Okay, Python file I'm going to create untitled. And now here, if I just do the import, okay, area. Now here this area is actually a function. So I will just import area. And now what I can do here is import area and I'll just write print area bracket 4. Now if I just enter it, okay, so see, I have gotten code saying import area is not a saved file, so I have to save it. So I have saved it. Okay. Now as soon as I do it, modding of found no modding area. Okay, its module name is actually py. Okay, py file. And now change the name of this one also. Let me just change its name. Wait, let me just remove. Oh, okay. Let me just remove that. And now I'll just do one thing. I'll just import area. Okay. And after this area, let me just create one more file. Okay, which says area.py. Okay. Now this is also a Python file, so I'll have to save it. So I'm creating it. Okay, now this area.py, what it does is it will get area, and then I will just write a pretty simple code right here, which is just using, which is by just using the map module. Okay, so I'll just write the import map. Okay, and then after this, I'll just click something. After this, I'll just write c equals to map dot py. Okay, and then we'll just give return c as clear, c as 15 as 15. Okay, so now as I just write import area router, and now I'm doing this right now. So I'm just going to itself model object is not following. Did you mean area dot area? Yeah, area dot area. So it's giving me the area of a circle which is actually four, which whose radius is 4. So if I just put 4 right here, see, I've got my correct answer already. 550.265. Okay. So what's happening here is this area is what the function is inside that module. And this area right here, let me just change its name here also. Let me just change its name as area 1. So right now here also I have to be area 1, right? So now as I run this file again, I'll get the same output, guys. So what's happening here is this area what is the name of that function, and this area is the name of the file. Okay, so that's how we can actually create ourselves our own modules. This really helps us to reuse the same block of code again and again, and it's actually very much helpful for us also, so that we can actually do some make some codes easily. Okay, now I have created, I have got myself some questions. Okay, I've got myself some questions today, which are some practice problems for you guys. So let's just do those practice problems one by one. Our first question is that our first question is we have to create a program and it checks if a number is an even or not, even or odd. So you could be saying that Harshit is very easy. So yeah, let's do that also, guys. Let me just remove these two right, these two from here, and I'll create a new file, rat.py. Okay. Now as soon as I just save it, okay, now it's a prank.py. So I just create a function there, even underscore odd. And after this even underscore odd, I have to put a number right here. Okay. Now after I have given it a number, I'll just write a simple if statement. So if a percentage by 2 is equal to 0, what we have to do is print, print it's even. Okay. And then after that, we'll put a elif. Okay. Elif a percentage if elif a is equal to 0. Okay, a is equal to 0. You know, there are three possibilities of a number. Either it's even, or it's odd, or it's 0. Okay, or wait, no, that those three possibilities will come when we are doing. the positive and negative. That question you guys will do it, okay? After this question, you guys will do that question, okay? So now we just put a else block really quick right here, else, and then we'll just write print, and after this print, I'll write odd, okay? Now as soon as I get my output, okay? So now I have to call my function, right? So I'll call my function as print, okay? Print even underscore odd, and inside it I'll just check my number as 45. 45 is my number, okay? So it must give me an odd, okay? So it is giving me odd, okay? I haven't returned anything, so that's why it is given a none right there also. As soon as I just write, instead of this print, I'll write the return statement, okay? So inside this return statement, I'll just write odd really quick. Now if I enter it, it is given me an odd right there. So that's how we can actually get that. That's how we can actually remove that none also from this. You guys will be asking that how can I remove that? So just use the return. Okay, when you're not returning any value, function will give you a none also. So let me just change my number towards a random gibberish number, which is 5.53664. Okay, so this number when I'm running code, it's even. So we have done the first question correctly, guys. If you guys have also done it correctly, then congratulations to you guys. So after this question, there is another question for finding the positive, negative, and zero. Do that function, create that function, and all do that one. Now we will check. Now we will have another question, which is largest of three numbers. User will give us three different numbers, and we have to check which number is the largest. Okay, so it actually uses the if else ladder really quick. So let me just create the whole function here. Okay. So I'll just write def largest. Okay, and then I have three of my at three of my parameters A, B, and C. And after this A, B, C, I'll just put it like this. Now I have to check if A is greater than B and A is greater than C. Okay, print largest number is comma A. Okay, and now let me just copy this print statement because I'll be having this statement all along with me. Okay, now in the next question, the next part, I'll just write elif elif B is greater than A and B is greater than C. Okay, then we will print, then we will just print one little thing. Largest number is B. Okay, now then there is this else block. Okay, this else block will contain nothing but just a statement. The largest number is C. Okay, now if I just assign some values, so my values are print. Okay, largest bracket 4 comma 56 comma 42. Okay, and now as I run my code out here, I'll get largest number is 56. Okay, so see again, there is a none we can see right here. This little none we can remove by eliminating every print statement as return. We actually have to return every statement. Okay, so we can actually, oh wait, see this is what the code look behind looks like for a print statement. Okay, it itself is a whole code of 2013 2,331 lines. Okay, so this is how a def print code actually looks like. See, guys, we have actually found it right here. So now I'll just write the return here. Okay, then I'll just remove that and put a space right here. For removing that, none will have to print the return. We'll have to write the return every time. Okay. Now, as I will just enter the code, it will largest number is 26. Okay, so see, we've got our outputs. Okay, right now. So now after this, there is one code. Okay, there is one code for you guys. You guys have to check if a year is a leap year. Okay, so for the given numbers. Okay, given number of years. Okay, then there is a fourth code to check print the Fibonacci series up to n terms. Okay, so our for Fibonacci series for n terms. Okay, we will be using our for loops. Okay, so for using our for loop, I'll just remove this code now. Let me just put n equals to 10. Okay, now after I have written n equals to 10, I can actually write, now as I have written n equals to 10, I'll have to write a and b also. Okay, so I'll just write a equals to 1 and b equals to 0. Okay, so what's happening right here is, oh, I have made a mistake. I have written a equals to 0 and b equals so a equals to 0. Okay, let's just write a comma b equals to 0 comma 1. Okay, this is more simple. So now what's happening here is we are actually working with the Fibonacci series. So what's the Fibonacci series? It's actually writing the sum of every previous value till the end. Okay. So now as soon as I just write for my Fibonacci series, the code is okay, for I in range n. Okay, for I in range n, we'll have to print a. Okay, range a comma n equals to this. Okay. Then after this, wait, have I done something wrong? For I in range n. Then there must be a tab right here. Okay, a tab right here. Okay. Now after this tab, I'll just write print a comment. And then after that, there will be a logic behind this is that now a comma b is equals to b comma a plus b. Okay. So that's a logic behind this. So I just write a comma b is equals to b comma a plus b. Okay. And now as soon as I just start the series, then give me the series as 0, 1, 1, 2, 3, 5, 8, 13, 12, 21, and 34. Okay, so this is how we can actually write the Fibonacci series also right now. So now after this Fibonacci series, there is one question for finding the factorial. That question will be done by you guys. Okay, you guys will be doing that question. Now after that, there is another question in which we are actually checking the palindrome. Okay, when we are checking a palindrome, the conditions for checking a palindrome is a num is a word that is actually that's actually spelled the same from the start to end and end to start. Okay, so when I'm writing a palindrome, I'll have to reverse a string right here. Okay, now for reversing a string, let me just create a function def. Okay, Inside that, I'll get my parameter A right here. And now after this, I'll just check for it. If, if A is equals to, okay, let me just create one more variable right here. B is equals to A bracket, colon, -1. Okay. Now, every value of A will be reversed in here. So now I'll check if A is equals to 2, print palindrome. Otherwise, we'll print else print not palindrome. Okay. And after this, as soon as I just call my function print palindrome, okay, then I'll just call it with the variable s. Okay. And after that, s. After that, I have to assign my s. So s is my map. Okay. Mam is a palindrome word. It will say yes, it's a palindrome. And as soon as I will just remove some, change this name to her, it it will say no, not palindrome. None. Okay, not palindrome. So that's how we can actually check for palindromes. And now after this, what you guys have to do is, you guys have to actually, now after this, what you guys have to do is, you guys have to count the vowels in the string, okay? So please check that out. Please do that by your own. And then after that, after that, there is a question that find the second largest number in a list, okay? So when I'm finding the second largest number, for that I can use a sorted function, okay? For after sorted function, I'll just call the call the character which is at index -2, okay? So let's do it then, okay? So when I'm doing it, I create a function def se dot largest, okay? Now after I se dot largest, I'll have to create one function parameter also. Now after this parameter is created, I'll be writing what? I'll be writing for my list, okay? So I'll just write s equals to list s equals to a dot sort. Okay, s equals to sort. Wait, what's happening here is let's see largest and then after that then must work. So it's sort a. Now after I'll just write the sort. It must give me a so s equals to sorted a. Okay. And then after this, I'll just type print second largest num is, then I'll just call the number which is at the second largest place. This a is equals a negative 2. Okay. So now after this, I'll create a list name L. Okay. The list is filled with some random numbers. Okay. Then after some random numbers, now I'll just pass this. Okay. So let's print second largest bracket L. No, as soon as I will just the second largest number is 51. Oh, what if I can do that? I have to put this S towards minus 2. Second largest number is, oh, wait, again it's 20. Second largest number is 50. Why? Oh, yeah, second largest number is actually 15. That's why it's printing right. It's printing there. But now if I just change my largest numbers to some random numbers, okay, and then I just put my largest number right here. So I've got my output as second largest number is this. So that's how we can check what's the second largest number. Here we have actually used the list functions, and then after that we have used the indexing, also negative indexing. So now after this, there's one question you guys have to do is sum and average of a list. Please do that by your own, guys. And then after that there is another question in which you guys have to do it also. You guys have to find the factorial while using the recursion, and another question is you guys have to find the GCD and LCM of a function. Okay, so these questions are some questions which you guys have to do by your own. Okay, if you guys want some more questions with these types, comment down below and I'll create another video for these type of questions also. Till then, take care, see you, bye bye, tata, and please keep problem solving and keep doing. In the next video, we will be covering the whole concept of object-oriented programming, guys, and that will be the last video of our session. Till till then, bye bye, see you, tada.